Welcome to the Explainer. So today we're doing something a little different. We decided to pick a random file from a massive formal codebase and just do a completely deep dive into it. And wow, did we find a wild one. It's a highly technical mathematical document called Polysemy as multiple waves. Now I know that sounds a bit intense, but what it actually proves is basically science fiction brought to life. It shows with rigorous math that human language, the very words we speak, operates as literal quantum physics. Yeah, you heard that right. Our brains are using the exact same wave mechanics that govern quantum particles to understand concepts. It's an absolutely mind-bending idea, so let's jump right in.
Okay, let's dive into this. I want you to just imagine the word bank. If I toss that word out there all by itself, your brain instantly has to deal with a split reality, right? Like, are we talking about a financial institution with vaults and ATMs, or are we talking about the muddy edge of a rushing river? How does your brain actually pick the right meaning? Well, in classical linguistics, we just say, oh, you look at the surrounding words and use context clues. But the math in our source document goes way, way deeper than that. It actually suggests your brain is calculating waveforms.
To really grasp how this works, we need to look at something called polysemy. Basically, polysemy is just a phenomenon where a single word carries multiple meanings. But what is so incredible about this specific source file is that it isn't just making some poetic comparison between words and waves. No, it rigorously proves them as topological standing waves. In your semantic space, both the money meaning and the river meaning of bank actually exist simultaneously as standing waves, and each one is stable at a different frequency. So literally, you are holding a quantum superposition in your mind just by reading a simple vocabulary word. How cool is that?
The mathematician behind all this laid out a roadmap of 5 distinct rules for how our brains calculate meaning. We've got metaphors as constructive interference, ambiguity as destructive lock, frequencies of meaning, superposition of sentences, and finally, context collapses the wave.
All right, let's start with Theorem 1, metaphors as constructive interference. According to the formal proof, a semantic domain is a coherent region of concept space. Think of an emotional domain, or maybe a technical domain. When you create a metaphor, you're taking a source domain and a target domain. And if the mathematical frequencies of these two domains perfectly overlap, their amplitudes actually combine. The source code explicitly defines this as constructive interference. It's exactly like two ripples on a pond meeting to form one much larger wave. A brand new meaning forms right at the intersection of those concepts. The math proves that a metaphor is at its strongest, meaning it literally has the highest semantic amplitude when both the source and target waves are individually strong and perfectly aligned.
Now, what's really interesting here is what happens in Theorem 2, ambiguity as destructive lock. So what exactly happens when waves don't align perfectly and our brain just gets confused? You know, have you ever read a sentence that was just so poorly phrased you had to read it 2 or 3 times to figure out what the author was even trying to say? Well, the source file defines this kind of ambiguity not as a simple mistake, but as a destructive lock. This is a state where 2 totally incompatible meanings just refuse to collapse. 2 standing waves are mathematically out of phase. Both meanings are trying to activate at the exact same time, but neither can reinforce the other. So that subjective feeling of being confused, that weird mental strain you feel when reading a terrible sentence, is quite literally that mathematical tension. It's formalized as the sum of uncollapsed amplitudes. Your brain is in there struggling to resolve a wave equation.
Moving on to Theorem 3, literal versus metaphorical frequencies.
How does the brain know the difference between something super obvious and something deeply abstract? This formal proof assigns actual mathematical values to different types of meaning. A literal meaning, the direct, obvious sense of a word, is mathematically defined as operating at a low frequency, specifically a frequency of 10 or less. Because it's a slow, steady, really common wave, it takes very little energy to process. But on the flip side, a metaphorical meaning operates at a higher frequency, greater than 10. And because of this higher frequency, the theorem proves it requires a larger context requirement and a lot more cognitive work to actually resolve. The math perfectly models exactly why poetry takes so much more brain power to read than a grocery list.
Shifting our scope from single words to entire phrases, we get Theorem 4, the superposition of sentences.
And this brilliantly illustrates a concept in linguistics called compositionality. That's the idea that the meaning of a complex expression is determined by the meanings of its parts. The proof takes this and translates it directly into quantum mechanics. Compositionality is simply linear superposition. When you put a sentence together, you're really just adding the amplitudes of the individual word waves. If a phrase is well composed, the total meaning is the perfect constructive sum of its component semantic waves. Your brain is essentially acting as a Fourier transform, instantly reverse engineering a complex sentence wave back into the individual word frequencies that built it in the first place.
And now for the real climax of the explainer. Theorem 5, context collapses the wave.
Let's move to see how this all builds together. We've talked about words floating around as multiple possibilities, but how does the brain finally lock on to the correct version? Well, here is the exact 5-part formal proof of how context forces a resolution. Step 1. The word arrives in your mind with multiple possible meanings, multiple standing waves. Step 2. The surrounding context arrives, imposing its own specific frequency signature. Step 3. One of those word meanings phase locks with the context through constructive interference. So, going back to our earlier example, if the context frequency revolves around money, the financial meaning of bank phase locks. Step 4. All the other meanings undergo destructive interference and are mathematically canceled out. And finally, Step 5, a single crystal-clear meaning remains. The quantum wave has officially collapsed into a single classical reality for the reader.
I want to take a quick second to read this exact quote directly from the source material because it's just so powerful. 5 standing waves, 5 theorems, 5 colors of meaning, no axioms, no sorry. The harmonics prove themselves. It is incredibly rare to see something so deeply poetic wrapped in something so strictly rigorous. When they say no axioms, no sorry in the world of formal theorem proving, that means there is absolutely no cheating. There are 0 unproven assumptions. The math is absolute. Language genuinely operates on these exact wave mechanics.
Which leads us with this final, kind of staggering thought to ponder. We've seen the absolute mathematical proof that our vocabulary, our metaphors, and our sentence structures are quite literally waveforms interfering with one another until context collapses them into meaning. So the absolutely crucial point is this. If every single sentence you speak is a quantum superposition, what else is your brain calculating as a wave? Your memories, your decisions, your very sense of self? Thank you so much for joining me on this deep dive in today's explainer. Keep learning, keep questioning, and I'll see you next time.